Welcome everyone to the third and final session in the February 2023 Cybersecurity with Python and the Microbit v2.0 workshop. And sorry, I'm on the wrong slide. I should be on day 3 of 3. Almost there. There we are. Okay, so today we're going to start out with just a little bit of review, then talk about the new malformed packets chapter that I'll be passing to Stephanie, most likely Monday morning. Some Cyberbot robot demos. Now, for cyber.org, Chuck Gardner was not able to be here with us today, so he's going to be joining us at our Friday session of the next installment of this workshop, which is March 3rd. So just a couple weeks away. And what I'll do is I'll send you a link to that meeting and let you know what time approximately we expect to have him speaking on Friday. And then afterwards, I'll also send you a link to the starting point of his session in the recording for that one, because he talks about some really great stuff. So I don't want anybody to miss out on that. Hope that's okay. After that, we'll talk about educator resources, upcoming workshops, how to buy the materials that we have talked about and showcased, some question and answers, and other wrap up. So that's what's coming today. For the review, or actually, first of all, let's all together make sure that we're ready to do the hands-on stuff when it comes around. So that's going to be connecting both your microbits and getting your python.microbit.org/v/2 editors up and running and connected to your microbits. So I am currently plugging the microbits into USB. And we can see that they are now awake. And then start Chrome. Where is Chrome? Okay, so here we have one Chrome. Take that to python.microbit.org. Oopsie, I want v2. In the additional time, we can talk a little bit about this v3 editor, but that'll be a little bit later in the session. Duplicate. All right, so hopefully you are all now connected to, oh yeah, and then I want to connect to each individual microbit. And then I'm going to quickly run one of these programs to see which microbit is connected to which editor. Flash. Okay. So now I know that this one, since it started running the default program, is the one that is connected to that editor, and the other one is connected to the other editor. All right, so the only review thing that I really wanted to talk about is just to emphasize in the encryption and other cybersecurity lessons, how they recycle some of the material that was used earlier. So for example, here we have, we're using the ASCII cipher to protect our countdown. So we're reusing the countdown application. Oh no, I apologize. Should be the countdown application. Why does that look funny? Okay. Yeah, I'm not exactly sure why. Oh, I remember now. Pardon me. So the discussion before we do this is saying, hey, look, if you're using the Caesar cipher, sure, you can transmit printable characters or words or even sentences, but those sentences better not have any punctuation. Whereas the ASCII shift cipher is using all 93 printable characters, which makes it possible to do stuff like transmit packets encrypted with all their punctuation. Some more things happening. There was some lessons in strings about, I know I went through it quickly, so don't worry if you don't remember it, but it's in there. The ORD function is the one that gives us a number in exchange for a letter. In other words, if you give it a printable character, it will tell you the ASCII, the ASCII code that corresponds to that letter. And then after doing some manipulations to pick a shifted letter in the list of printable characters, then let's see here. Yeah, then it says, okay, well, now that we know the index of the new character position, the new ASCII character, let's go ahead and convert it back to a character and then add that to the result. And so these are things that were introduced in strings. This was something that was introduced in dictionaries. And so that's one example. And then moving on to encryption. No, there's not going to be a lot more there. I'm trying to remember an example of something that uses, we just talked about strings and dictionaries, exception handling. Actually, that is primarily coming up, I just realized. So that's going to be in in malformed packets, which we'll be talking about shortly. So that being the case, I think that's enough about reusing previous material, in addition to the fact that oftentimes we will revisit some of the previous applications. For example, in encryption, we revisit texting with terminals. Is one of the items we revisit. And then another item would be the radio data, the data exchange. So this is the dictionaries part going through the encryption. So this was alluded to earlier in the chapter. And then here we have the actual sending a dictionary with the countdown information and receiving it with another microbit. So just another example of how material is reused as the chapters continue to move forward, that we're relying on a scaffolding of what was introduced earlier. This is the Cyberbot robot. Each one has a microbit inside it. And notice that there's a microbit connected to this laptop. So what's going to happen here is that Ken is going to type some commands into the keyboard. The script he's running, what it does is it takes the speed it questions him, what speed do you want the left wheel to go? What speed do you want the right wheel to go? And then how long do you want those two wheels to maintain that speed? And those are all the ingredients of a rolling robot maneuver. And so he types those in, and then when he hits enter, it goes into the computer, out the USB, into the microbit, out the microbit's radio, and all these Cyberbot robots receive the same command. So I'll go ahead and play that. So here he's entering the wheel speeds, and then there they all go. And he's entering very short run times for them, but it's kind of neat. You can actually get the whole classroom to go with one commands coming from a single computer. The reason that this is useful from the cybersecurity standpoint is it gives us another vector. It's also relevant to cyber attacks on electromechanical and factory equipment. So it's definitely a nice addition for those who have the time and are able to purchase some Cyberbot robots. The Cyberbot robot tutorial series, as I mentioned on day one, is a superset of the tutorials that we've gone through or examined during this session and that students will go through. Most of these prerequisites probably look familiar. Like here we have dictionary primer and exception handling, strings and characters. The place where we get additional chapters are the robotic and circuit part. So for example, here's one on how to put together the robot. Here's one on navigation. Here's a chapter on sound and one on LED lights, contact sensor. And there's lots of other sensors, light sensors, infrared, that's a non-contact kind of sensors. And there are also some additional projects, including that come with that are supporting add-on kits. So all of these chapters here support the stock robot as well as keyboard control, whereas right here is keyboard control and tilt control. There's also some add-on kits, for example, a line follower and a ultrasonic distance sensor that can be rotated back and forth on a standard servo turret, and the TV remote control. So these are basically all the additions that are part of the Cyberbot robot that you won't see in the cybersecurity. And what they do is they just kind of take the lessons and give one more form of reinforcement. And again, it's very applicable to industrial robotics and the need to protect our manufacturing and military infrastructure. So here is the microbit front and back. And this is the Cyberbot board. And the way this works is that the microbit is plugged into the Cyberbot board, and then it looks like this on top of the robot. There's a parallax designed propeller microcontroller on the Cyberbot board. And so when you plug the microbit into the Cyberbot board here, it has it communicates with this microcontroller and actually makes it do the majority of the tasks. And that opens up some room for having two processors do separate things. And one of the main advantages of having this separate processor is the resolution with which you can control the servo speeds. It's much higher with this microcontroller than it would be with the microbit. Here's an example of reinforcing some of the earlier lessons with the Cyberbot robot. The lesson I'm setting up to talk about here is for loops, basically repeating a piece of code a certain number of times. With a robot, you can, for example, write a little routine to have it go straight forward. And these are the statements that do that. And then you can write a routine to have it turn right by about 90 degrees. And so, and then of course, stop after it's done. Now, by putting the forward and turn right routines into a loop that repeats 4 times is a nice way to have the robot go forward, turn right, and then repeat 3 more times to draw a square. And so I've always thought that that was a really nice way. Well, it's a nice example of how the robot can be used to reinforce quite a number of the techniques that were introduced earlier on in the programming basics chapter. After navigation lessons are done, then sensors can be added to the robot. And I'm just going to take a break before showing you what that looks like on the video. Oh, well, here we are. The video's here too. The chapters are very similar to the ones you're working through. So if you're, the main difference is that there's an electromechanical or electronic component to it. And in this case, it's electromechanical, at least what the students are building. They're just basically adding some parts, and these parts that they're adding are called resistors. And one of the things that we like about this is that they're real world parts. They're not a magnet that connects to another magnet with a resistor symbol on it. This is a real resistor that's used in real electrical and electronic devices. These whiskers are added to the robot. But aside from that, there's testing that happens. You know, you after loading the script, you test the whiskers, learn how they work. And then there's some kind of application with, you know, solved code that they can try, and then how it works, and then taking it to the next level. Sometimes we supply the code, other times we supply instructions to put your hand on the keyboard. In this case, we're supplying the code because it's kind of a large step to take. It's not really something that escaping corners is not necessarily something that would be a fair next step without lots of additional hints. So, so in this particular case, we're including the whole solution. But there are other challenges for the students, which I'll be talking about in the assessment materials. So this is what the whiskers robot looks like. So here he is. He's got these contact sensors, or these extensions out front, and when he runs into the box, an electrical change happens that the microbit ends up detecting, and then it tells the servo motors to back up and go a new direction. So that's one of the examples from the Cyberbot. You of course saw initially the keyboard control. That's one of the great ones, especially for cybersecurity. Here's another one that involves light sensing, and the chapter is a similar setup. And in case you didn't catch it, Okay, the flashlight's coming up right now, and it got shined on the robot's left sensor, so it turned left toward it. The whisker design is great for introductory, basically introducing a novel application of circuits that you can touch, see, and feel. But there's also infrared, which is light that you can't see, but it does respond similarly to the whisker sensors. And then, of course, this was the keyboard control that I showed you a clip of initially. And again, these are all chapters. And this is just an example of what, what the keyboard control script looks like. I'll be also talking about upcoming courses in case any of you are interested in getting a Cyberbot robot if you don't already have one and taking the course. There are also previous courses that you can find and follow along with the YouTube recordings, just like this one will soon be a previous course that everybody can find and follow along with. So this is the full application for the transmitter and the receiver for tilt control with a keyboard. And there's the video again. I'm sorry, keyboard control, not tilt control with a keyboard. On the keyboard control note, or pardon me, on the tilt control note, happy Friday, everyone. Here is an example of the microbit, again, connected by a radio. This time, the microbit that's being tilted is powered by the battery pack that comes with the microbit. And if you look closely, hopefully you can see that there are some lights that are showing the general direction that this microbit is being tilted. And if you look closely at the Cyberbot, it displays corresponding lights so that you can see on the Cyberbot what direction it's supposed to be going. I really like that application. It used to be that for our original Bobot robot that this is descended from, folks used to have to buy a couple of different add-ons to make all that work. Radio add-ons and accelerometer add-ons. And since the radio and the accelerometer for tilt sensing are both built into the microbit, it makes it so that we don't have to charge anything extra, and you get this nice application for your students to try out. And this one, by the way, is also some classes have adapted it to sumo wrestling. So they put a plow on the front of the robot, and then they use the tilt controller to control it in a sumo ring. And there would even be an opportunity to have a group of hackers and defenders as part of the team for each sumo bot. We haven't done official instructions for that yet. It's just something I recommend that people try because I think it's very, very doable. There is also an electronics series, electricity and electronics series for the microbit. This is one that this is completely different. It's a different kit. Well, I mean, it still has a microbit. So we do have some prerequisites that look familiar, like writing microbit programs and computer microbit talk. Then you can pretty much from there jump into, for example, setting up the breadboard or taking electrical measurements. Let's see here. And electricity and electronics can be kind of challenging. So one of the things that we tried to do here was really go all out with the illustrations, so that we can introduce, for example, how the electrical connections underneath these sockets in a thing called a breadboard for prototyping are used. And so we show, for example, that if you have a wire that's in a different row of 5 sockets, it's not connected. But since 2 wires here are in the same row, yeah, they're connected, but the 2 pairs of wires in different rows are not connected. And it goes on through all the different options, and students with the video support can actually, or if you're lecturing about it, you can actually stop the video and talk about, okay, how and why are these 2 connected even though they're on the same row, but those 2 are not connected. And then the chapter goes into, well, gee, it's because the rule is rows of 5. It shows the breadboard taken apart, and that there are little plates with 5s that are underneath each row of 5 sockets, with a valley in between where there's no metal connecting the plate on this side from the plate on that side. So there's lots of stuff that is, I don't know, I always thought it was kind of challenging to learn. And so what I tried to do was make it easier. But also there's a lot of theory in electricity and electronics. And so I did what I could to give students some real world experience. So we actually have a thing called the Cyberscope, and the Cyberscope here is functioning as a voltmeter, and the students have built a circuit, and the Cyberscope is actually just connected. It's the microbit taking measurements and then forwarding those measurements to the computer. And then the computer, if you go to cyberscope.parallax.com and download and run a script that's there, well, actually, you'll want to download the script that is on this page, measure volts with Cyberscope. Then you can have that real world experience of using a voltmeter without having to have voltmeter equipment. What's more, you can even use the microbit as an oscilloscope. So here is an example of the very brief light on signal and the amount of time it lasts that controls a standard servo and what direction it points to and holds with its armature. It's called a horn in hobby electronic speak. So the servo horn is pointed to different directions based on a repeated series of very brief light on. If a light circuit was connected to it, the light would turn on. And so this series of brief on signals is, which are denoted by these high pulse looking things here, are what control the armature. And so in the Cyberscope, there's also an oscilloscope option. Oscilloscopes are very hard to get, or rather, they're usually at least $400 a piece. And so it requires benches that you put the oscilloscope in, and they have to be locked to the bench so that they don't get carried away. But now students can actually have the experience of taking measurements of those brief on times with this online oscilloscope, which again is just the microbit taking measurements. So it's basically like having a $20 oscilloscope, because the web page is free. I guess while I'm on the subject, I'll go ahead and show you whoopsie, version 2, and then cyberscope.parallax.com. All right, so it says, so you can actually do this without making any circuit connections by downloading try-cyberscope.hex. And then, and there's a little video that shows how to do all this on the slideshow on the Cyberscopes homepage here. So you can play the video and see the exact steps to try it out without having to use any circuits. So I'll just show you because I kind of have that video memorized. We'll open Try Cyberscopes. Cyberscope, going to, whoopsie, didn't mean to do that. We'll disconnect that microbit and then connect to it over here. Flash. Disconnect. Run over to the Cyberscope and hit connect. Hope I got the right one. Possibly not. There we go. And so here's the oscilloscope part. It's sending sine wave and exponential decay data, which are things that are often measured with oscilloscopes to determine problems with electrical circuits or to make sure that they're working correctly. And then there's a series of meters that are used. Like this is the ammeter, which measures electric current, the voltmeter, which measures electric pressure, and then the resistance meter, which measures devices that slow down the flow of current through a circuit. And for those of you who are familiar with oscilloscopes, there's also some pretty cool features like the trigger feature, where the entire image, instead of marching across the screen, will line up to a pair of lines that are placed on the screen so that the measurement will stay still even though it's repeating periodically. Okay, so that's all I've got to say about the Cyberscope and the electronics kit that is just kind of another thing you can do with microbit modules that has a series of tutorials on learn.parallax.com. Next up is cyber.org. Again, since Chuck will be with us on March the 3rd, I'm going to defer most of that to Chuck. The only thing I'd like to say is that they have curricula for that uses the microbit. And if you're a United States teacher, you can, and you're not already able to access the cyber.org resources, you can hit sign up and let them know that you really are a teacher, and they'll check and make sure you're a teacher and then grant you access to their curricula, which is also that they have parts that have computer science elements and parts that have cybersecurity elements. And it's the kind of thing that can be mixed and matched with what we have published. And in some cases, there's some crossover because we did a lot of the development as a team. And again, I'll let you know when to expect to see Chuck or when to see a video of it, both actually. All right, about upcoming workshops. See, I just saw a couple of chats come up. Okay, excellent. And I'm seeing a comment, great resources at cyber.org. The cyber range is a great tool. Yes, I agree. The cyber range is a system that you can go to with a web browser. And in that web browser, you can actually run multiple computers. And in one, you can do some of the things, students can do some of the things that used to be successfully done that they don't use the latest technology. So most of it's not going to actually do any current damage, but they actually do cook up viruses and cause other computers to get infected and examine the symptoms and disinfect the computer manually of the virus to have some real world experience. And then there's also a certification that students can work toward. Let's see. Okay, and then I got that would be great. Let's make sure to, I'll make sure to send everybody that link when I know when Chuck is gonna, basically I don't know yet what time Chuck will be joining us. It'll be sometime on March 3rd from in the let's see, in the 3 to 5 Pacific time range. So it's going to be a couple hours later than this set of workshops. And so it'll be Friday the 3rd, sometime between 3 and 5. And as soon as we nail that down, I'll go ahead and let you know when it's going to be. I'll send you the link shortly before the workshop, and then I'll also send a link to where it appears in the YouTube recording of the workshop, probably the Monday that comes after the March 3rd. As far as upcoming workshops, if you go to parallax.com, so there's a link in the slideshow. If you just click the image of the upcoming events, there'll be a little link that appears down below it, which is what I followed. So I'll do that again. Now, you can also simply get here, if you go to the Parallax homepage, there's community and events. And I'll just paste that into the chat as well. There you go. Upcoming events are here, and these are the educator workshops. We also have the Parallax Propeller microcontroller. This is these events are for electronics professionals and experts for the most part. The educator workshops, obviously, you kind of know what they're like, and the ones that we have coming up are a repeat on the cybersecurity. Don't worry that it says closed. I will send you a link so that you can get in on Friday. After the repeat on the cybersecurity, we have one coming up for the Arduino, one coming up for the Cyberbot robot, which I did the keyboard control demo, and those videos that we looked at were all the Cyberbot robot. And then we've got the electronics kit with the Cyberscope that we also talked about. And then this is the Parallax Activity Bot, the last one, the last workshop we have this spring. It's May 1, 3, and 5 is for the Parallax Activity Bot. This has the Propeller microcontroller that, again, is designed by Parallax. It's programmed in Blockly or C language, and it has some unique motors that are that have the ability to know what angle they have turned to, and that's pretty cool for automatically straightening out the robot's path. If you're using the Arduino Shield robot here, which is programmed in C++ inside the Arduino shell, or the Cyberbot, which is programmed in Python, one of the things you have to do is to get the robot to go straight ahead, exactly straight, as opposed to a slight curve in one direction or another. You have to adjust the wheel speeds a little bit to straighten it out. So these are the upcoming workshops. Now, on this events page, there's also a past events link. And so here, for example, is a previous event where I basically talked about what's coming up. But if I go here, I don't want to watch the YouTube video, but I do want to look at the slideshow for this for just a second, because there's a slide I'd like to share with you that lists the previous events. And where did it go? I believe this is it. So this is the At Your Own Pace page. So this lists the previous installments of the upcoming workshops I just talked about. So if, for example, you have a Cyberbot robot and need to get up to speed before the upcoming Cyberbot robot session, you could use one of the past events, and you can even email me with questions and I can help you out, even schedule a Zoom meeting if if we need to go over anything in depth. So I'm going to post a link that should take you directly to that slide for a while. You can bookmark it or copy and paste it into your notes. And that'll save some searching, because it does take a little bit of scrolling and going to the next page. Like if we go back to past events, I think okay, so here's one previous educational event, the electronics kit. Oh, actually, so they all are on the front page, right? Or most of them are on the front page. So you could scroll down and just find those as well in the past events. And there are 3 more pages of previous events. And oh, one more thing. So like with the Cyberbot robot, if you go to the event, all 3 videos are linked at the top of the page. Then you've got the description. And then at the bottom of the page, there's the presentation slides. So the previous events are also a nice little way of, if you need to go and revisit something, think to yourself, oh, gee, I think I remember Andy saying thus and such. Let's see if that's really the case. You can go back and, find the event you went to, and then look at and then follow the YouTube and or slide links. And so the workshop that we're in today will appear in past events probably early next week. Learn.parallax.com is both the resource for students and instructors. And yeah, let's see here. I think I'm going to, I just realized that I meant to jump into the hands-on with the malformed packet attack and defense chapter. And so keep your microbits connected to your computer, and do be ready to start running microbit programs. In fact, you know what? I think I'll leave. Well, no, we'll just, I'll talk about the instructor materials, and no, I want to get started before we take the mid workshop session break. So so the next thing I'm going to do is I'm going to paste you a link to the chapter draft, which I believe Stephanie's going to start posting to learn.parallax.com next week. Bear with me a second. Okay, share, whoopsie, share, copy link. All right, so this is the draft. It has a lot of extra stuff that you won't see when it makes it to the web, or rather it's going to be separated into instructor and student material portions. So this is both. So here comes that link. It's a Google Doc. So again, this is before it reaches the web. This is what it looks like in development. Stephanie, what do you think of my malformed packet?
That's great.
She hasn't seen that, or I just did that last night, I think, so she hasn't seen it. All right, so malformed packets. For one thing, this is definitely going to be depending on a whole lot of stuff leading up to it. So I made a fairly extensive list of all the pieces that students will want to have done before then, hopefully to intercept students who try to just jump right in and expect to understand something that's at the end without having gone to the beginning. Countdown timer yet again. So let's take a look at how a malformed packet can affect our countdown timer. So what I would like you to do, let's see, I don't know how much these guys are going to fit into the chat. We'll try it. So this is the transmitter. Okay, so that did fit. And let's try the receiver. I think some of these scripts are going to be too long. We're right at the edge right now. Okay, but those transmitter and receiver scripts did make it through to the chat. So go ahead and take those and paste one into one microbit and the other into the other microbit. I will do the same. And of course, it is recommended, again, to have the tutorial side by side with the editor and type it in, but for the sake of covering as much or surveying as much of the material as we can, I'm taking a shortcut with the script with the understanding that you may need to go back and do this in more detail to feel like you fully understand it. And so then if I connect both microbits here and flash them both, it should work normally with normal values. Okay, so here we are at the start. And basically this one is just saying that it's the countdown receiver and this one is the countdown transmitter. And so it should just work normally as is. So the first thing I want everybody to do is test to make sure that it works normally by, doing a countdown start value and then a message after the countdown. And what should happen is that the radio should transmit to the receiver, and then the receiver should do the countdown just as it's done for us before radio connected. And last time, I think we encrypted the message, and this time we're just making sure that it works normally. The unencrypted version, actually. Now, what the instructions in this chapter say is, hey, students, take a look at this little stub that has been added to the transmitter app. And what it's saying is that to send a malformed packet, you can use the value -1. And what this will do is it'll substitute whatever integer was here, or the receiver is expecting an integer right here. So it expected that 3 or a 5 or a 10 or whatever the number is. It does not expect a string. And so from the receiver standpoint, this malforms the packet and causes a lot of trouble. So I'll show you what happens. And some of you are probably trying this. If you put in -1, and then it doesn't even matter what you put for the countdown because it's going to cause some trouble for the receiver. So I'll just hit enter. And notice on the receiver end that, yeah, that not a number came through. That's fine. And it sees that it's not a message. But this little thing right here, the trace back most recent call, that is telling you that an exception occurred. And it displayed a frowny face, and it's trying to tell you this same message on the LED matrix display. And guess what? If you try doing another countdown, so I'm going to try to run another countdown. Oh no, I lost the server. It's not responding. It just finished displaying its error message. It's its exception message. And so I'll try it again, but nothing's happening over to the right side. And nothing will happen until either you load the new program on, or remember there's a reset button right there, right next to the serial, right next to the USB port. So you can press and release that reset button. And then now the receiver is alive again, and you can give it some valid data and it'll keep doing its job again. Thing is, it received a malformed packet and it became unresponsive until the IT had to go in the server closet and reset the thing. So this is an example that's kind of similar to, what can happen. We also talk about the fact that malformed packets are used to potentially gain entry by confusing a server or to just get it to stop working. It's also sometimes mixed in with denial of service attacks. In other words, instead of just flooding a server with attacks that it's going to deny, you give it malformed packets that actually causes the denial instead of packets that it's processing. And again, that's used sometimes to make the server unresponsive or gain entry to it. I haven't been able to figure out how to do a gain entry example on the microbit, but I think this is still pretty illustrative of a problem that can be encountered with the microbit, using the microbit to illustrate this. And so so those were the scripts, and then these are the test instructions. Once it makes it to the web, these little black check marks will become red check marks that you've probably seen quite a few of. And this image accompanies the instructions. And so this is the part where we're just testing it and making sure it works. And then this is the part where we're testing it and verifying that it breaks. And then how it works goes into, and by the way, these are elements that you'll see in most of the tutorials. And so how it works goes into the details of what happened, what the transmitter did to actually cause this, and how it was caused inside the receiver microbit. After that, there's a try this, and the try this, note that, okay, so the code is completed right here, but this code goes to the teacher materials. And so the students have this, they have to put, for trying this, they have to put their hands on the keyboard and make the adjustments to their code. And I mentioned earlier that try except exception handling is used to prevent this kind of thing from happening. And that's especially relevant also in web pages. You don't want the web page to freeze up, so there has to be a certain amount of exception handling to make sure that any data coming through is something that the web page, the JavaScript can process properly. All right, so let's try the solution to this. So we're going to paste this into the receiver microbit. So close serial. So countdown receiver is the one you want to take and replace it with. And let me see if that'll make it through the chat, or if we have to all go find it. Nope, we got to all go find it. I'll show you how to find it. Pardon me. All right, so along the left, there's going to be a little, what looks like a bulleted list icon. And when you click it, if you can't see the outline like this already, go ahead and click that little show document outline. And then what I want you to do is in malformed packets and the countdown timer, find the receiver script changes section. So left malformed packet and countdown timer, receiver script changes. Let me see if I can zoom in on that for you for a second. Okay, so malformed packets and the countdown timer, receiver script changes, and then go ahead and grab the red script that's below what the students will use. That's this part. And paste it into your browser. So again, this comes with the teacher materials, not the student materials. The students get this image to work from. I'm sure some will actually go through the effort of running it through a scanning software that'll spit them back the text, but I doubt that it's going to be perfectly indented and everything like they'll need. Okay, so select all, paste, flash. And then what we want to do is repeat the same test. So we'll open Serial again. And then we'll try and keep an eye on your, I don't remember if I displayed anything with the microbit or just, the next one does display stuff with the microbit. That'll be fun and we'll do it right after the break. So here is the countdown timer. And so if you enter a start value of 2 and up, it does its job normally. And then if we try to trip it up with -1, now that it has the exception handling added to it, oh, that's weird. Oh, I didn't hit enter. When I hit enter, it'll say that there was an exception. Okay, because right now I just have the kind of part of the script that would tell a developer that there's an exception, and we haven't refined it to the point where it is a user-friendly message saying, you know, please don't send a negative value or something like that. So, but to prove that it still works, even after that, you can try another value. And we can see that even though that exception occurred, the microbit did not crash and it does not have to be restarted. And by the way, the restart is a particularly relevant penalty, again, in a robot race where your robot becomes unresponsive in the middle of the course. And if you're not allowed to go and restart it, well, that's a motivator to make sure that exception handling is addressed in your script. Just before we go to the break, I do include little pieces of knowledge in here, like in Did You Know? We talk about this kind of activity of testing and mitigating vulnerabilities in software as being something that an application security validation specialist does. Then in the Your Turn, which I'll leave, it's basically more of the same. I don't know. We can do it or not. But what this is doing is it's saying, hey, this is not, you just fixed one thing, but did you fix everything? Is this application really hardened? And Stephanie didn't have to catch that one for me. I just corrected a typo I noticed in the draft. Our editor-in-chief will still find many, I'm sure. So what this does is it says, okay, how about if you add a stub, another stub to your transmitter script that sends a different kind of malformed packet? And in this case, the kind of malformed packet it's sending is, it's basically sending a string that does not contain a dictionary. And when that happens, even though we already took one step to harden the script, guess what? It doesn't work. And so the students go through basically another round of, testing, observing the exception, and then mitigating it by modifying the exception handling. And in the case of this one, all they had to do is they basically had the try statement just above where the exception occurred. I think it was value equals value minus 1 is where it choked because it received a string instead of an actual value. And so they had try right about here. And so what this screenshot is doing is telling them, move try up here and then indent all those ones that weren't indented. And then you'll have your running script. And of course, we have the running, the working script here as well for the teachers. Then there is review and practice with some self-assessment near the end. And then note that I don't have all the color coding correct. I still have a couple more hours of tuning on this, but notice that the odd numbered questions are the normal color, and then the even ones are red. So that's my message to Stephanie to plop these even questions into the teacher materials. And so we go all the way through, and we have exercises and also projects, and all of them you'll have solutions for. And then we'll, after we take our break, we'll start sending some emoji back and forth with a considerably cooler program than we used back in brute force. So it's 2:04 right now. I'd like you all to come back at 10 past the hour, if you would. So, or I'm sorry, it's 4 past the hour. If you could all come back. No, let's make it 12 past the hour, give you 7 minutes, just like we did every time before. So we'll see you at 12 past the hour. And so this is a short break, and I'll go ahead and I can still take questions. Remember, we're still recording. And we'll go ahead and insert the taking a break slide right before 76.
This is a reminder, we're still recording during the break.
Okay, are we back? Can I get some thumbs up? Thank you, Kevin. Catherine. Sarah, oh, outstanding. Christine, beautiful. All right, welcome back, everyone. Let's talk now about a second microbit only example for malformed packets. And this one is, again, it's a share something. It's like share something personal from I think it was sniffing attacks. It may have yeah, I may have incorrectly said it was brute force, but I believe that share something personal is in sniffing attacks. And that script, to keep it simple, was just sending 3 different emoji over and over again: a smile, a frown, and an angry face. This one is set up so that you can use buttons to select emoji that you send across the radio ether. And let's see here, where's the chat? Let's see if this one pastes in. It does. Okay, so here is another one. This is from malformed packets and sharing something personal. It's basically the second activity. So malformed packets, the countdown timer was the first activity. Now we're in the second activity and we're in the script section. And the name of it is radio_send_receive_images_w_buttons. And so, so we're going to get this, and it should be in your chat as well. And this time, put the same script in both editors because it's a transceiver script. All right, flash. And we can look at it over serial. I believe we'll see some things when one microbit does receive a packet. Okay, so what you'll do with these is you'll use the A button here to select the image to send. Now, please don't use the skull yet, because the skull is the test one for sending a malformed packet. So here's let's send the X. That's the, oopsie, I reset it. Okay, here's the X. Man, try it from below. So here is the X. And when I press so you can use the A button to scroll through your images, and then use the B button to transmit it to the other microbit. There we go. And notice that the both terminals are showing image .no, which is the name of this image. And then you can use the A button to choose a different one, send it. You can even go to the other microbit and use the A button to select a different image and send it to the first microbit. So this is a full bidirectional. And then now that we know it works and we see the exchanges both, on our microbit displays, what I want you to do next is page through until you do find the skull. And when you press the B button to send it, you'll notice that a frowny face appears over here. And then it starts talking about where an exception occurred. I think it looked like on line 33. Yeah, and then you can see in the terminal that it occurred on line 33. And now if I try to send any more images, nothing happens. So again, it's caused the microbit to stop functioning. So let's fix that. And by the way, here are the instructions to the students. So we just did what we just did was the script. And then we ran the tests to see how it works normally, as well as how it works when the microbit sends a malformed packet. Early instructions also prompted the students to take a look to find the comment in the script that says sends malformed packet, and take a look. And in this case, it's if the image variable stores image.skull, then change the packet to a string that's essentially nonsense to the receiver. It's not what the receiver is looking for. Then down in the how it works, for this particular script, instead of just talking about the relevant portions to malformed packets, it talks about the entire script, since students have not seen this one before. And of course, included in that is a discussion of if the image is skull, and it goes into that in the paragraph. And try this. The students get to try the solution. Again, that solution is as a screenshot, as opposed to the actual coded solution. So what you'll want to do, maybe this one's not too big, but I think it is. I think that I can't paste this into the chat. Yeah, it won't let me. All right, so this time in the contents, you want to go to the second try this. It's in malformed packets and sharing something personal. Try this. And then scroll past the screen capture, and you'll find the teacher code. And what we want to do is paste that into both, because it has the exception test, or the malformed packet test, and the exception handling added. By the way, here is the exception handling. This is just wrapped around from the previous line. So here's our try and our accept. So this is designed to say, basically, if anything bad happened while trying to process or display that emoji, then print the exception in the terminal, flash the display with a sad face rapidly a few times, and then go back to the original image that was being displayed before the problem occurred. Okay, close serial, close serial. Okay, then make sure to flash them both. And then we'll take a look at opening serial. Okay, so we won't see anything, but in the thumbnail of me, if you'll direct your attention there, we will again select an image and make sure that the normal stuff still works. Yeah, they're communicating. And then we get to the infamous skull. And when we send that, notice there's a frowny face that flashes 3 times, and then it went back to what was originally being displayed, which was the heart. I'll resend that one. And see, we go back to the heart, and and it continues from there in the sequence of images that you can page through. So nothing stopped working, everything just continued, and in this case, it told us about it. I left some silent failure handling to the projects in this section and the previous one as well. And also note that it does indicate in the terminal that there was an exception. Folks, were you able to get that to go? Did that work for you in your testing? One thumb up. Okay, I just have one thumb up so far. 2, 2, 3, thank you. Can we get to 5? 4, thank you. 5, yes. All right, good job, everyone. And so let me know if moving forward is still a little too fast, because we can give you some more time. All right, so another did you know item is that, gee, we solved the malformed packet problem, but right now the script is unencrypted. So anybody could watch it or join in and send data that wouldn't be rejected. So let's put both into the same script. And so we have one image for the students where they basically add the function that does the encryption. And then the second image for the students where they call the function that encrypts and displays it in the terminal. And then on the receive end, so this was the transmit end right here. Then on the receive end, they print the encrypted version, then decrypt it, then print the decrypted version before continuing through the rest of the script. So these are the modifications. Basically, add the function and then call the function. And it also talks somewhere in here about the fact that you'd be using a stronger encryption module if you were using Python on your computer as opposed to MicroPython with the microbit, which does not really have the memory to hold those large encryption modules. So now we are in the same sharing something personal, malformed packets sharing something personal, but this solution is in the your turn. And again, this goes into both. And from the standpoint of what you see on the LED display, nothing is going to change. But what you'll see on the terminal will look a little bit different, just because it needs to prove to the students, I'm hoping, that they are encrypting their data before sending it out. So again, in the thumbnail of me, I have the 2 microbits, and so I'll pick an image and send it. And then advance to another image and send it. Now we'll send the infamous skull. And it flashes, and then goes back to the heart. And I can send the heart. And so everything still works. So we know that the exception handling is still working. And why is that? I expected to see some encrypted. What did I do wrong? Sorry, folks, I did something wrong. It's supposed to be printing the encrypted packet. I probably forgot to flash these guys. Open serial, open serial. Okay, so I'll go ahead and test these real quick again. Send. Okay, there we go. So now we can see it working in my thumbnail, but we can also see it encrypting in the terminals. And we can see that there was an exception, but not a lot more, because this is just a more basic example. We're mainly focused on adding the encryption in, so that's the important part here. The reason I'm doing that is because it's not easy. This gives students some experience with adjusting and maintaining a larger program, which is something that, you know, certainly when we started off, we were looking at scripts that were a line, 3 lines, 5 lines, and they've been growing since then. And so these are pretty, you know, here at the tail end, these are pretty sizable application scripts, and the students are now getting experience with how to go in and change a larger script that they're presented with, which happens in the tech world a lot, because if there are layoffs, then some coders have to go to new companies, and at those new companies, they have to be able to work with a larger script and the instructions that are left with that script in whatever application they might be using or developing, pardon me. Any thoughts on that? How do you like it so far? This is new stuff, so I'm interested in feedback. If you're not wanting to unmute, just go ahead and yeah, yeah, no, don't worry about being slow on a thumbs up. Okay, so I got one very cool. Thank you very much. I'm really like to see that. All right, so I think we'll probably end up stopping with a few minutes before the 2-hour mark. So I'm hoping to just get a little more feedback. And also, you know, you guys have the link. So if you want to try it out this weekend, and just let me know if you find any bugs or any misstatements or anything that should be added, just go ahead and drop me an email. Again, we have our questions, exercises, and projects all solved, but what's on the web will not include the solved stuff. Then we have now a Cyberbot robot version. What I'm trying to do is build the foundation for a contest where the students actually have enough tools to fend off cyber attacks and on their robots. And so what this activity does is, let me see if I can actually switch over to, I'm going to mute my video here and see if I can bring up a Cyberbot robot, and we'll do this in real time and hopefully not have it go sideways. Let's see here. So mute my video. Okay, so my video is stopped, and then I'm going to open up my webcam directly. Okay. All right, so here is a Cyberbot robot. This one has some some infrared test circuits on it that you would not need for this. This does not need any circuits because it's just the keyboard control. And so I'm going to remove the microbit that's in there to save time. And then we'll go ahead and put, I don't know which one I'm going to need actually. So what we'll do is we'll first start out, and this is the sender script. The controller script is another one where there's a stub that's been added to test sending a malformed packet. And that's right here. And basically, if you give it a negative amount of milliseconds to execute the maneuver, what it will do is replace that integer with not a number, and that will cause a problem that's similar to the one that we did at the beginning of the chapter. Okay, let's see. Did I do the transmitter already? I think I did, yes. Okay, so now we want to do the receiver, the vulnerable one. All right, so let's flash this and see which one is which. Boy, I already have an error. Oh, I forgot to add the Cyberbot module to this. All right, so this is a good review. So at learn.parallax.com, going into the Cyberbot tutorial, Cyberbot tutorial series, there's one called Add Modules to Your Microbit. And in there, there's it shows how to do it, both downloading and unzipping, and how to add it to your project. And so I'll go ahead and go to the archive, download the zip, show it in Finder or your Files app if you have a Chromebook, or File Explorer if you have a Windows machine. And here is, you can unzip it by double clicking, or you may have to right click and select extract all files or something like that. Then we can go in, and there is cyberbot.py in my downloads, and cyberbot MicroPython. Either one of these folders is going to have it. It looks like I downloaded it before. All right, so we'll go ahead and hit load save. And this is just a quick thing for those of you who are going to be using the Cyberbot robot. Show files, add file. And then I happen to already be in that folder, the Cyberbot MicroPython. And so cyberbot.py is right here. And this is a subfolder, I believe, of downloads. Okay, so we hit open. Now we've got the cyberbot.py module. And when I flash it this time, there won't be an exception. Open serial. Okay, so I believe it's just waiting for me. All right, so we'll enter the left speed of, oh, you know what? The fact that it didn't say anything has me thinking that maybe I have the wrong microbit plugged into the Cyberbot. So let's see if that really is the case. So what I'm going to do, first of all, is turn on power. Maybe that's Plug in battery, turn on power. Okay, so nothing's happened over in this screen. So I'm thinking that maybe this microbit is the one that's waiting to talk to the Cyberbot robot. There we go. Now it says ready. So it's ready for some navigation instructions. So here's the transmitter, and then here's the receiver. And I can actually I could disconnect this, but I'm going to leave it connected so that we can see what's going on here. And so I'll go ahead and type in okay, so we'll just do a short little move forward. Let's go very low speed, 20 on both wheels, 20 out of about 130. And then for the milliseconds to run, we'll do a second. And it's not moving because I accidentally left the switch in the power to the sensors only mode as opposed to power to the sensors and motors. So I got to try that again. And there it goes. Okay, and then we'll back it up. Roughly to where it began. Okay, so now I know, and by the way, again, that's 20 out of 130. So it can go a lot faster than that. All right, so now let's test the malformed packet and see what happens. So we'll do a negative value. Oh, you know what? Yeah, so we can do any old value for the speeds, but it's the time to run that we want to make a negative value. When we do that, we get a frowny face on the microbit, and then it displays the error. And worse still, it's stuck running around in circles. The cable's not going to let it keep turning around in circles. But if I try to give it a new set of commands, nothing happens aside from that it's so tangled up in its cable that it's not, not able to continue turning in circles. So, so this again is a nice tangible way of showing, hey, look, machines are vulnerable to these kind of things too, because we have networked machines and these things can happen. And also, personally, if you want your remote control robot not to get hacked, it's important to take measures to prevent that. So again, try this is where the mitigation occurs. And then the your turn in this case is just another round at encrypting the data along with the mitigation. Now let's see. I want to do this in the receiver. Okay, so controlled bot. Don't even need to flash that. It's still the same thing. But we do need to flash the code to mitigate the malformed packet attack. Okay, so make sure it runs correctly first. Okay, so what something happened here because I'm still rotating in place. Flash. Oh, that's interesting. Okay, I'm going to reset the microbit. I'm not seeing that ready signal again. Or maybe I did not properly paste over. Let's see, now there's the try and accept blocks. So that's what it should be. So I'm setting the thing to 1, connecting, flashing, and opening the serial. There we go. In this case, I had to, for whatever reason, hit Control D to reset to get the ready signal. And then we'll connect to this one. All right. Set the power switch to 2 so that motors get power. 20, 20, 2000. Okay, how about 30, 30, 2000? There we go. Okay. We'll go ahead and back it up. Now what happened? Oh, so I accidentally just entered a negative value there. I meant to do -30, but instead I entered the negative value, which sent the negative value, and it's telling me an exception occurred, and it flickered some frowny faces here, but it should still respond now if I tell it to say go forward again. Oh wait, I want to do 30. There it goes. Okay, so I'll do the exception and keep an eye on the display here. -30. Okay, so I'm going to use a negative value, so it should send the malformed packet. And so watch here and we'll see some flickering, hopefully. Did that come through? I don't know if it was a flickering frowny face and it says an exception occurred, but again, it still works. Ta-da. All right, so that's the last example from the malformed packets chapter, and it's we always put or I always try to put a Cyberbot robot thing right at the end of the chapter to keep the Cyberbot robot as part of the cybersecurity lessons. Hopefully that was somewhat eye-opening. And then that is the end of the malformed packet. Well, I mean, there's also the again steps for encrypting it, which are left to the students, and then that is the end of the chapter. And after that, learn.parallax.com. This is your main resource for the students, as in when you get right to learn.parallax.com, that's where the students are typically going to start. And depending on what hardware they have, be it the ActivityBot, ShieldBot, Cyberbot, SumoBot, BoBot, etc. All of the tutorials are right here. And cybersecurity is, of course, down here. And so the students would follow this if they're using just the microbit, or they would follow the Cyberbot link, of course, if they're using the Cyberbot robot. The learn.parallax.com, going back to the homepage, is also where your educator resources are. And here we are with the cybersecurity resources up top. Now, if a student tries to go in here, all they're going to see is things that are not assessment materials in available downloads, and it's not very interesting. It's not going to be very interesting to them either. So here are some teaching and strategy guides that we have available for download. And each one of these talks a little bit about, what we like in terms of assessment and how, formative is preferable, and that we also make available some summative assessment materials. I guess that's here. And so those are some recommendations and tips. And then here are some more tips in the strategy guide. And I think that I don't remember why we added the activity bot in here. It may be relevant to just how the yeah, I'm not sure why it's there. Stephanie, if you can tell me, then we'll know. I guess
Just
go.
a typo. My apologies.
Oh, so that needs to be removed.
I'll take a look at it.
Okay, thanks. Yeah, I mean, I can see that some of the activity bot scope and sequence is useful for the cyber bot, but I'm not sure that we want to have it in the.
It's just the wrong one linked.
Okay. Then students cannot get to the assessment materials. So what I'm going to do is open an incognito window and then take that to another screen and log into the assessment materials to show you what's there. Okay, learn.parallax.com. And basically what I'm going to do is I'm going to go to on that window, I'm going to go to learn.parallax.com and then select educators. And then there's a login right at the beginning of the educator page, and it asks you for your login info. And so I'll do that off screen and bring it back on screen in just a minute. Educators, login, my info. I'm being a bit fumble-fingered today. Okay, got it. All right, so I'm logged in now. And if we go back to the Learn site and then go back to educators and back into the cybersecurity materials. You know what, Stephanie? I may have gone to the wrong page to begin with, because this looks like it has a lot more good stuff here. Okay, teaching and strategy guides. So this is all general stuff. Like these are the public web resources, and then the teaching and strategy guides that we took a quick look at. And then now that I'm logged in, and now that, yeah, and when you log in, you will be able to see, instead of a giant lock that says, you can't go here unless you apply as an educator, we have the actual assessment material. And so we can download a couple of these, like let's take a look at, we'll take a look at exception handling. And we'll take a look at encryption. So those are now in my downloads. So then they each need to be unzipped. And so here is exception handling, and so here is, we always have a PDF and an RTF, which is a Microsoft Word friendly format of the teacher materials. And let's see here. Okay. Yeah, I forgot that oh boy. Yeah, my computer just fired up a virtual machine to try to open it in a virtual Windows machine, and I don't want to do that. Let's see if I can open it with okay, here we go. All right. So here's an example of the kind of handouts that come with each chapter. And then there are also solutions that we ask you to keep to yourself, along with the scoring rubric. And I went a little bit too slow, so I think I'll just leave it at that for the educators section of the Learn site. And just so you know, these are all the chapters, and that are cybersecurity, and so you can go ahead and download those and get the assessment materials that are provided for each chapter. Then a couple more items. First of all, Parallax is a microbit channel partner. We are one of the more widely used suppliers of microbit modules. And so if you go to www.parallax.com, what you can do is hit shop. And then along the left, there's an all things microbit category. And so this shows everything that we have that is either a microbit or a related kit that goes with it. So we have, for example, the Cyberbot without the microbit, because we know many of you already have microbits. Here's the 2.0 club bundle. That's 10 microbits all in one box. 10 microbit Go kits in a club box. Conversion kit for those of you who might have BoBot or ShieldBot robots. The gripper for the ShieldBot robot, or yeah, for the gripper, which can be used on the Cyberbot, and so on. And it just keeps going. And so here, for example, is the Microbit 2.0 Go bundle. And if we look at this, some of you may have been inconvenienced or even had a really tough time during the supply chain shortages because the Microbit Education Foundation's manufacturing was affected by that too. And so we did everything we could to keep material available. And now we have a significant cushion. So anybody who had to put off microbits and might still need to get some, we've got plenty. And so yeah, these are all the microbit things. And I will go back one and share that link with you. Copy. Paste. I think I missed a direct message. Okay. Let's see. Here's another one. No, that's the same one, pardon me. And we have an educator hotline that's open 8 hours a day. Here is the phone number. You can also get a prompt response and just the right person to reply by emailing education@parallax.com. Stephanie, Ari, Ken Gracie, and I think our senior software developer, Jeff Martin, are all on that list. So if you need to have the right person reply to you, just email education, or if you need especially an immediate reply, like if you're having some tech problems in the classroom, call this number. And we have a sales line for stuff like purchase orders, a discussion forum, Facebook channel, and we actually have lots of other social that you can find right on the Parallax homepage. If you scroll to the bottom, there they all are: Facebook, Twitter, YouTube, and so on. And cyber.org sends a thank you for attending this workshop, and thank you from Parallax as well. And I'd love it if some of you could stick around, especially I forget who I was speaking with on Wednesday, but there was mention of, gee, there's kind of a conundrum on vocabulary because not all students necessarily know what vocabulary is assumed. And so I'd like to hear more about that and possibly how we can update our documentation to help.
Yes, Catherine was also mentioning that there's a decent amount of prior knowledge that's required for students also, which related to Wednesday's post-class discussion. So I too it would be great if that conversation could happen. Yeah, we would like very much to hear more from you, and especially if you're aware of certain resources that we can look at that you feel actually fills that gap, or possibly just itemized suggestions on filling the gap, or we'll do whatever we can to make it more accessible to you and your students. The other side of this is that this is something that's intended to be after students have had fun with the Microbit Education Foundation material. So another topic along the same lines would be, what is the appropriate entry level? And are we hitting that mark, or are we missing it? And if we're missing it, what can we do to fix it? So that's one of the topics. And then we're interested in finding out anything we can do to better serve you. So for those of you who have a few extra minutes to stick around and talk about those topics, we'd love to hear from you. And thanks everybody for coming. We'll go ahead and stop the recording now and move on to the educator discussion portion of the workshop.